This video is going to show you how to find the surface area of a cuboid, a triangular prism and a cylinder. You'll need to know how to find the area and circumference of a circle to fully engage with this video. So to start then, what is surface area? Well, it's the area of all of the faces of a shape when added up together. So for example, with a cuboid, it's the top and the bottom face, the front and the back face, and the left and the right hand side of the cuboid. The area of each of those rectangles or squares added up together gives you the total surface area of a shape. If we look at an example of a cuboid, this cuboid's got dimensions of 4, 10 and 3 centimetres. We'll look at the front face first. If I copy out the dimensions, we have a 10 centimetre height and we have a length of 4 centimetres. That gives the area of the front of this cuboid as being 40 centimetres squared. The next face, if we look at the side has the same length of 10 centimetres and it has a width of 3 centimetres. So that gives this face an area of 30 centimetres squared. And then we also have the top of the cuboid, which has a length of 4 centimetres and it has a width of 3 centimetres, which gives us 12 centimetres squared as the area. Now, because it's a cuboid and because of the properties that we know of cuboids, we know that the front face and the back face are going to be the same size. We also know that the left hand side and the right hand side are going to be the same size. And we also know that the top and the bottom are going to be exactly the same size. Therefore, when we work out our total surface area, we can double each of these areas. So that means we've got 80 centimetres squared plus 60 centimetres squared plus 24 centimetres squared. So that's going to give us 140 from 80 plus 60 plus 24, which gives us a total surface area of 164 centimetres squared. Now, if you are doing this in an exam, you can either do it this way by finding the front and the back and doubling, or you could find the area of all the faces, add it all together, so 40, 30 and 12, which would give you 82 centimetres squared, and then you could double it. Either way would be fine. Now, if we're looking at a triangular prism, it's exactly the same concept, looking at each face, except you have to be a bit more careful because you can't double any of the rectangular lengths, because if we look at these separately, the sloping face has lengths of 10 centimetres and 9 centimetres. That gives us 90 centimetres squared, whereas the base of the triangular prism has 10 centimetres as a length, and then this length here is 8 centimetres, and so that gives us 80 centimetres squared for that face. We then have the, I guess you call it the left hand face. So if I pull that out, it had a height of 6 centimetres, and then this length here is, this length here is the same as this length here, so that's 10 centimetres, which gives us 60 centimetres squared. And then we've got the two triangles at the front and the back. So these will be the same, so you can just double these answers. And if I take that out, I'm looking at 6 centimetres and 8 centimetres. So to work out the area for this, it's going to be 6 times 8 divided by 2. So that's going to give you 24 centimetres squared, which means this back triangle here is also going to be 24 centimetres squared. In the exam, to make this question harder, what you might find is that they don't give you this length of 9 centimetres here. They may expect you to use Pythagoras' theorem to work out what this length is, to find this sloping, the area of this sloping side. So make sure that you can find Pythagoras' theorem. There's a video available on the channel for you to see how to do that. So then to find our total surface area, it's going to be 60 plus 24 plus 90 plus 80 plus 24. So it's 5 values, 5 faces. That's 8, 6, 8, 17, 25, 26, 27. Just going to count that again to make sure. 10, 2 and 8 is 10, 19, 20, 27. So that's 278 centimetres squared in total. Okay, so the final thing we're going to look at then is finding the surface area of a cylinder. This is split into two main sections when answering this question. The main thing is that you can use the formulas to find the circumference and the area of circles to be able to find the surface area of a cylinder. So if we look at the top and the bottom of the cylinder first, we should see that we have on the top a circle. On the base we're going to have the same circle, and then round the outside, if you think of this being for example a baked bean tin or a tin of fruit, and there was a label on here, if you think of peeling that label off, this shape that you end up with is going to be a rectangle. The height you'll be given and this length along here would be exactly the same as this length around here, if you imagine the label being stuck onto the can. And we know that this length around the outside of a circle is the circumference of a circle. So to find the the area of this rectangle, you'd have to do the circumference of the circle times by whatever the height is of the cylinder. So let's have a look at an example to see how this works. So looking at an example for the surface area of a cylinder then, if we take the top of the cylinder, if I open that out so you can see it as being the full circle that it is, this circle we know has a radius of 3 centimetres, and you should know that to find the area of a circle we use the formula pi times r squared, which is pi times 3 squared. Doing that on the calculator, we have a solution of 9 pi, which is 28.3. Now, because if you imagine a cylinder, it's just, for example, a tin of beans or a loo roll, cardboard in the middle of a loo roll, the top and the bottom of the cylinder are exactly the same. So if I pull this base out as well and then open it out into the circle that it is, it will be exactly the same size. So this is also going to be 28.3 centimetres squared. So that's the top and the bottom. Now, thinking back to what we said about the outside of the cylinder, to work out this surface area of this face, we need to think about laying out, if it was like a label around a tin, laying that out flat, which would be like a rectangle. So if we pull this label out, we need to work out what the area is of this rectangle. So we know it's got a height of 8 centimetres, but we need to work out this distance here. Because this label is going to fit exactly around the cylinder, this top ledge here would go around the edge here of the cylinder. So we need to work out what the circumference of this circle on top of this cylinder is. So this is going to be pi times d, which is equal to pi times 6, because diameter is double the radius. We put pi times 6 into the calculator, we get a solution of 18.8. Therefore, to get the area of this rectangle, it's 8 times 18.8. Which gives me an area of 150.4, and that's centimetres squared. We're then going to add onto that solution the two circles, so 28.3 plus 28.3, and then that will give us the total surface area, which is 207 centimetres squared.